This is a continuing video on this power feed. Here's a gearbox, a quick change gearbox. I had this business right here, which is a double U joint to drive the feed screw. Because it wasn't quite straight, it would go fast, slow at a certain point. It sort of pulsed the speed. So what happened here is here's a piece of material. It's kind of dirty right now, but what it was doing was putting fine grooves or some sort of harmonics about every 4 or 5 turns. As it speed up and slow down, it was putting grooves in the workpiece. Here's a pretty good example of that. You can see here these fine grooves in this piece is because of the variation in the speed of the feed. Now here's a pretty good piece right here, and also right here. But if you compare these two pieces, now this is the one in the back is the one I've done by hand. I'm trying to make a shaft that fits better, and I'm trying to get all of the tolerance out of this lathe. But you can kind of see here that I don't know how well this camera is even picking this up, but it's really not that good of a finish. Now this piece back here is one that I've did by hand. I just because I don't have any obviously gearbox on here now, so I had to feed this in by hand. What I'm doing is making a new shaft. I'll show you what that goes for. Now here's the old shaft. This was the end of the lead screw that I cut off, and what it does, it goes into the gearbox here, and of course there's a gear that goes in here that rides on this, and then it turns in the case. Now this is I don't know if you can see here, but that's a bronze bushing. It's a kind of a copper thing, and it actually acts as a bearing, and this piece here goes in there and turns. Now I don't know if you can see there, but I've got quite a bit of movement in this thing. A few thousandths. This is probably just because of the wear that was on the shaft itself. It was a little too long. I have a big long groove in it here for a key. You know, this half round key goes in there. But anyway, what I've done here is I'm making a new piece. This is going to be this piece here exactly, but I'm increasing the size of this by a few thousandths so it fits in the box tightly, and it'll be a little shorter here. Various things to make this whole setup a little tighter and a little more exact. Now I did make something that fits in the lathe. Now this is the old piece of the shaft. I turned it down so my gear and thing will go on here, and I've got enough room to put a good bolt on it. But basically, I don't know if you can see there, but there's there's quite a bit of play still in the shaft, but I did figure out a way to do it. Put everything on here where it's the right dimensions and so forth. But rather than try to use this shaft, which was good enough, but I need to adjust the dimensions and everything of this, and that's what this new one is going to be. This shaft here is 3/4 of an inch. Let's throw a caliper on it there. It's a 755, and this one is also looks like it's about 755. Yeah, but this one should be 750. Yeah, so what I've got is 2 or 3 thousandths difference between this new shaft here. So I've got 760 there, 760. So this is 760. This one is 750, 755. I've made this a few thousandths bigger, so like when I put it in the case, I won't have this movement that you see here with this one. I don't really like this this movement here, because that is letting it egg shape walk around. And this one, once I get all of this part here for it to hold the gear and the nut and everything and get it threaded, then I'll cut this off, and then I'll just take a emery cloth or a file or something, and I'll take, you know, 1/2 thousandths, 1,000 off at a time until this one here fits good into the case and I have no movement. But right now I'm going to start marking things, and we're going to turn this down to the right diameter. It's not so easy with one hand, but here's the gear, and if I check this with the calipers, it shows that it's 720 is how big this has got to be, or I'm sorry, 620. So this is about 5/8 or so, and that's how big this new shaft has got to be cut here on the end so it can hold the gear. So I've got to take off about 100 thousandths or so. So that'll be the next thing, is to machine this down to hold this gear. I have to leave some room in it to thread, and the end of it is going to look like this when I'm done. This basically is a setup that I need to turn. I've got a spacer in here, and then I'm going to put this on here. I have to leave myself some room to thread it, because I have to thread it by hand. I can't use the automatic threading feature on the lathe. But I got a shaft or a spacer here that'll set against the gear, and a nut that'll tighten it all up against the shoulder on this shaft. So basically I have to duplicate that shaft here up in this other part. The first step is to mark off how far I need it, and then turn it to the correct diameter. Alright, I've marked this with a magic marker. I'm just making the first pass on it here. See, I'm doing this by hand. I've got quite a bit to go. Of course, I can't keep an even speed. I'm trying to here, and you see I'm doing a pretty good job. But there's no automatic feed. I have to do this by hand. The more even speed it is, of course, the better the finish. I had to let go and turn my hand. Now I'm just taking it up to that line, which is 1.25 inches. Yeah, I'm going to dial in another 20 thousandths. That's a pretty big cut. I just keep going until I get this down to where it fits on the gear. Alright, I made a few passes. I'm going to check this here. Looks like I've got about 645, and the gear is 625. So I've got about 20 thousandths to take off of this. So what I'm going to do here is, this is a complete. I'm going to take off. That shows 8 thousandths, so that should be 16 thousandths cut. And I can take this one here pretty fast. I'm doing this by hand. And you can see that it's cut pretty good there. And I'm able to pretty much keep a steady pressure on here. You can see little lines in the material. This is it. See, I stopped and changed my hand. Now I'll feed it again. But I'm trying to make a pretty even pass across here. I should be within about 4 or 5 thousandths. I'll have to measure it exactly. And then put the gear on here and see how close I am. Getting close to the end of my cut here. Alright. Now I'll measure this again. And it says that I'm at 630. And I need 618, 620. So I'm gonna just go ahead and finish this little part up, and then I'll show you putting the gear on it. Alright, I've turned this down. I've got about maybe 2 thousandths. You can see this moves a little bit, but the important part is this shoulder here. This will be perfectly square, which should hold this the gear on here. Now these are not terribly precise gears, but I do need all of the angles and the shoulders square, so when I bolt this thing down, it'll hold it in the right position. So now I'm just going to clean it up. This is good enough for what I want. I actually made it a little too small, but really it is not going to make that much difference. Right now I just have to clean this shoulder up right here so that the part fits on it properly. I'll run my tailstock in here. And I'm going to get over here to this section, turn it on. Now this should be cutting a shoulder on this thing. You can see the chips coming off here. And now I'm just going to back it out. Alright. Back it out a little more. Now I'm just going to feed this thing in here, and this should give me a perfectly square shoulder. And I'll just keep going until I see it make a mark, and I know I've got it to the right size. Even if it's just a little under, that's alright. And I think that is about what we need to do. And Feels pretty good. I'll crank this back out here. Get this out of the way. And see how our gear fits on it. I've got a little piece of fine stuff on it. Yeah, now that's square. So now I got a square shoulder. This fits on it perfectly well. I have a spacer that now will fit on there. Now I just need to thread this end. Now since I can't thread this with power feed on the lathe, what I'm going to have to do is mark how much I need here on the shaft. Now I'll see if I can do this. I just marked this shaft where the threads have to go past this in order to hold this spacer. Well, here's the size I want to use. This is 7/16 National Course 14. So what I'm going to look in my engineer's handbook and see how big this diameter needs to be. And according to this, the major diameter is 436 to 4206 at the minimum. So I'm gonna shoot for 4300 here on my little shaft. And right now it is about 575. So I got a long ways to turn this down to be the right size to use this threading implement on here. But I just wanted to check and start now to shoot for the correct size. Alright, I just measured this. I basically have 435 thousandths, and I have 436 thousandths, so I'm like a thousandths under. Means that this should be a good size to use this die on. And so now I'll do a setup here to start to thread this little piece. Alright, first thing I'm going to do is just bring it in here real slow and cut me a little angle on it. I'm feeding this in by hand. What I want to do is just start. For some reason this is not cutting here. Move this in. Let me lock this carriage here so it don't move, and I'll try to feed it in again. Oh man. See, the problem is that this is really not held perfectly true without the steady rest. I've got 3 or 4 inches of it poking out here, but I do have a little taper on it, which should be enough to start the threading. Now this is a little tap holder that I made. It's basically pressing straight in, keeping everything parallel. I can load it here, and as I turn this to thread it, of course this is moving in a little, and that's two-handed job. And then over here I give it a little more pressure, back to a little more threading, a little more pressure. So anyway, this is pretty tight. I can see it is starting to cut the threads. Let me put a little oil on here, and then I'll go ahead and thread this because I need both hands to do it. Alright, got it threaded, nut goes on good. It looks like it's tightening down good on the collar here, and everything is very solid, and there's not a lot sticking out. So basically that's good enough for now. I think what I'm going to do is just tighten this up just a little bit. It's kind of hard to see where I'm going with this, so I'll just give that a quick tighten. I want to clean up this bushing a little. Not for any reason other than just to have it look pretty. It makes no difference at all. That's good enough. Now it looks like it's running crooked right now because when I was threading this thing I wound up twisting the shaft in the chuck here. But anyway, everything's on there good. The next thing I have to do is cut some kind of a groove in this shaft to hold a key to keep this gear from turning on there. I've got quite a bit of pressure, but of course it just feels like there's quite a bit of pressure on there from your finger when you turn a half a horsepower into it'll slip, and if it slips, this is the main screw drive. So in normal cutting it really wouldn't make any difference, but if I'm cutting threads and that thing slips, it'll mess up my bolt. So anyway, next step is to figure out a way of getting a groove in this thing. Well, I've got a long piece of key stock here. There you can see there. This will be good enough. It's really should be a little bigger, but I think it'll work. I don't think I've got any bigger stuff. I've got a lot of stuff here. This is pretty much all standard sizes. Yeah, and I've got a store-bought key here. It's also too small. Anyway, the point is that I have to measure the distance here between the piece of key stock and the edge of the hole there, so I can tell how big of a groove I have to put in this. And there's a little trick of doing this with a tail piece of a lathe. I'll have to make a cutting tool, and I'll show you how that works. Now the way I'm going to do this is a piece of high-speed tool steel. If you notice, it's quite a bit thicker. So what I need to do is grind down this end so I can force this up in here one pass at a time and tick off a few thousandths. But I need to have the tool the same width as this here. So now I just go to the grinder and start working on the tool. Alright, you can see basically what I've done here is make a sharp tool that is basically the same width as this shaft, and what I'll do with it is take it and just force it in like this, one pass at a time, just scraping off a few thousandths. You can see right there I made a mark on it just by doing it by hand. But that's what I'll do, is lock this, put this in the cross slide, and then I can just mechanically cut a groove in it. Of course, I have to have it exactly on center and stuff, but that shouldn't be too hard to do. Well, here's basically the setup. I'm taking in a few thousandths. You can see there that it's hitting, but the problem is that this is not a real strong setup, so I need to probably use an end on here and probably change the angle of this, because basically I'm just scraping it off. I'll try a different setup it's here and see what happens. Alright, as you can see here, this is taking this down just a few thousandths at a time. All I'm doing is just doing it by hand, and then I put it in a few thousandths. Just keep doing the same thing. This is cutting a groove in it. Of course, this takes some time, but without having what I need for the correct cutting implement, I just keep doing this until I get the keyway cut to where I want it, and go from there. Now there's the end result. It's a pretty tight fit. I don't really have it perfect. You can see it's moving around a little there, but it just has to keep this from slipping, because we're going to have a collar that goes over it. You can see there that it's still a little too big. I might just grind just a little bit off of that. I'll make this custom fit. I wound up playing around with it and I broke my little cutting tool here, and I don't want to take time to make another one. But I basically have this done. It'll come off of there fine, and this is going to be good enough for what I want. Now the next thing is just to go over here and cut this shaft off to where I want it, and then we'll see what happens on putting it in the transmission. Well, here's our finished piece. Oh, just barely starts. In fact, it won't go in all the way, so what I'm going to do is I'm just going to chuck it up here again and make a couple passes over it with some fine sandpaper. Well, I took a thousandth or so off. Yeah, it doesn't goes about halfway. So from this side, about the same. That end I don't really care about. This is the end that's the business end. And it's starting in there. I'm not exactly sure what it's hitting. Probably this is not exactly round, but I'll just take a little more off of that that end there until I can get it in up to this point, and that should do it. Alright, well, I went over it in the lathe with a fine file and some sandpaper, and I probably got 1 or 2 thousandths. It's going in fine from either side. This way is a little tighter, which is fine. It's kind of hard doing this one-handed, but at any rate, I've got it a little tighter towards the gear end, which is good. But anyway, there's that. Probably just a little bit of oil would help things a lot. Oh yeah. Yeah, that'll be just fine. See, it's snug as it's going in, which means that when I put it in from the right side, it'll hold it very tight. And yeah, it goes through nicely. So the gear will hold it right there, and this end's what I'm going to have to drive the new U-joint that I come up with. I'm not exactly sure what's going to happen on that. I think this is supposed to be 3/4, so let's see. What do I have here? Yeah, 760 is just a little bigger than 3/4. 770. 750, so it's like 20 thousandths over. Might be a little in my measuring of this thing too. Yeah, so it's 10 thousandths too big. 10 thousandths is not very much. If I have to, I'll put it back in. But now I can go through here, and I'm going to clean up these gears and stuff a little better now that I know that it works. And I need to put a groove in these things because they're hitting this edge right here, not allowing me to shift gears very well. So anyway, this shaft is done, and we'll move on to the next step. Well, here's the next step. Now you can see this end here. It's not turning properly. It's bent. I think somebody probably dropped it or dropped something on the handle. So here's a set screw that takes the handle off, but the pin's going to go in here and hit this gear. And the hinge of this gear, or the pin, it looks like that's probably a press fit, so I'll have to punch this pin out and then take the gear out, and then I can get the rest of this off. Well, I took the handle and the gear off. It won't come out this way at all. And then I found another set screw here, and this is some kind of a little collar in here. And let's see if I can find something that'll fit that set screw. There we go. And now this should just tap out. It's a two-handed job, so I'll take that out and see what we can do about straightening that pin. Alright, I got it out. As you can see there, the pin is bent. What I'll do is put a gauge on it and see how much. Well, I set it at 0. You can see that it's out about 10 thousandths, and if I need 2 hands again, if I go up in here to this one, see the big one's out about, oh man, that's 25 thousandths. So not only is just the end bent, but the whole shaft is bent there about 25 thousandths. So I'm going to try it on the small one here. See, the small one is off about 20 thousandths too. I think I'm going to check my chuck and make sure it's running true. Well, this is a ground bar that I know is straight, and it looks like the chuck itself is off about 15 thousandths. So I don't know, maybe I've got something in the threads or whatever, because I know this chuck was running within about 2 thousandths before. So I'm gonna fool around with my chuck and see what's wrong with it. First thing I did is check my chuck itself, my spindle. It's half a thousandth, so it's got to be somewhere in these threads or in the threads of this chuck. So anyway, I know this is straight, and so I think it's pretty much has to be in those threads. I'm going to clean everything up and see if we can get it to run any better. I don't know how well you can see here, but I see little pieces of dirt and metal shavings and things here inside the chuck itself. So I'm just going to clean that up, and then we'll see what turns up. Now I put the backing plate in, or the clutch, or the chuck in, and I'm checking it here on the backing plate, which is this piece here, and I've got a little paint on here to keep it from rusting, but it looks like the backing plate is within the thousandths. And if I come over here and if I can get this thing moved in, that's not very good, but see, I've still got about 5, 10, 5, about 17 thousandths. When I get in closer to the I need to set this up different. There we go. See, I've still got, I need to set this up a little better. I've got this on that test bar again. So it shows 17 thousandths. When I move it back and forth, yeah, it's showing it straight, so got about 17 thousandths. I don't know whether this is in my jaws or what. I'm going to try moving this part around and see if I can get it any better. I cleaned the jaws real good there. And it's still showing me about 13 thousandths. Which is actually quite a bit. As I get closer to the jaw, I still got 12 or 13 thousandths. So probably my jaws are off 12 thousandths. So I could go to a 4-jaw chuck to straighten it out, but I'm just going to polish up that little part and see what I can get when I put it in. Alright, I put my little pin in there, and it's still showing about 13 thousandths. So that's within the tolerance of my jaw. I don't like that, but that's what it is. And I'll clean it up, and if I can get I'll try to do something to get it a little straighter so I can straighten that end. Alright, collar on the pin. Looks like it's within 10 thousandths. And the end, yeah, let's find us a 0. We're going to set a 0 here. Okay, so that's off 45 thousandths. So I know it's off 45 thousandths. And we have a 10 thousandths in the pin. I'm not sure which way it's going, but I need to move that 40 thousandths, which is quite a lot. It's half a tenth. And you can see that it's pretty well bent. So I'm just going to chuck it up real tight and try to put a little tube on it and take that bend out of the very end, because this other part here, I can get this back in here, both hands on the edge of the pin. See, I've only got about 10 thousandths. So 40, that thing's been at least 30 thousandths. So we're going to try to straighten it out. Well, the first thing I tried here is putting a nut driver on it and trying to bend it. And it don't really want to bend. Pretty tough. Not exactly sure what I'm going to do here to do this. I hate to pound on it, especially when it's in a chuck. I may have to just make a new part. But anyway, before I do that, I'm going to go ahead and see if I can get this thing straight. Maybe I can heat it and do something with it. I wouldn't have much luck with anything. What I'm going to do is bore a hole with this drill bit in a piece of bar stock, and then make a tool to try to bend it with. Well, that worked pretty good. I just put a hole in this, and then I had plenty of pressure on it, and it looks pretty straight. I'd probably say that's within limits of the chuck. So it looks like we got some success on this one. Now I can just clean it all up, put it back together, and I'll see what I can clean up here. Next little modification. When I tried to shift these arms, one-handed, especially this one, when it's up inside there, I pull it down and these two lower places here just wouldn't go in, because you can really see there it hit the bottom. So what I did was hog a big chunk out so it misses the bottom of the lathe there. I've put the shaft in it, and it all works really good. When you pull it down, it's got plenty of room, and even down here in the bottom it still lets the shaft go in. I probably weakened it, but there's not really any force on that thing. So it's still plenty good. And I had a little trouble getting this mounted in because it's just a casting and it's not really square, and the vise didn't want to hold it right. But anyway, I got that done, and so that ended my shifting problem. And the cutter worked really good on big old cut of cast iron. Cast iron's easy to cut, but yeah, it took everything out really good, and didn't mess up my head or anything there. So that's it for shifting. And this here is just stuck on here temporarily right now. It's not really in good. I was thinking about machining off this edge here to where I could have a straight press into this. I don't know if I'll mess with that or not. It looks like it's going to be pretty hard to mount this up in here. Again, I really don't have a big vise or anything. I'll take a look at it and see, but I think the whole thing is going to be hanging off of here, and I'm not really sure what's going to happen. I may be able to grind it, even with a hand grinder or something. Just get it close. Basically, I need to take about a 10 or 15 degree angle out of this to where it's flush with the, or parallel rather, to the lathe bed, so when I bolt it down it holds real good. But anyway, I was just kind of in a hurry to get it on just to see if it'll work. Well, now I know it will work. So now the next thing is to make sure that it's all right and bolted in good and solid. Alright, I'm trying to mount this gearbox here on the lathe. I cut a slope. You can't really see it very well here, but cut a slope there on the bottom. It's not flush to this surface, and so when I bolt the bolts up, it wants to hold it crooked. So I'm going to machine it off. Right now I'm just trying to figure out how to clamp this thing in. I've got another nut here. I think this one here will work, so I'll just keep going until I can get myself a clamp. Alright, here we are at the end of the travel. I'm going to take this in until I touch. I'm taking the part closer to the head. Alright, there it is against the case. I'm going to raise it up now until I touch. Now I'm going to back it out, see where I am. Yeah, that's fine. The hole where the bolt goes is this one right here. Kind of not doing this. I'm doing it one-handed, so that's the correct bolt, so I just need to take it. If it's starting right here, I'll take it to the center of that bolt. I'm just going to take this whole thing down. So I run it back to my travel. There's where it stops. I'll bring it up until I make contact. And now I just turn on the power feed and let it do its thing. I'm not using oil on it. Cast iron is pretty soft. I'm not really shooting for any particular dimension, just that it's square from one edge all the way over to the other. It'll take several passes. I got it all lined up good. It's making a 10,000th pass right now. Feeding in at a pretty good rate. And I'm setting off 20,000. I just have to let it keep going until this gets this edge right here shows up, and then it'll be split. Well, it's getting pretty close. You can see right here that I'm probably within a quarter of an inch of the edge. So I've got it set up over here to stop. So I'm just right at the end. Probably one more pass will make it go back. I'm just backing it up right now. Might be boring for some of you, but some of the others might be interesting. At the end of my travel, I'm going to put another 15,000 in. 5, 10, 15, do the automatic, and away it goes. Alright, well, you can see that it's all the way across, and you see that little tiny ridge right here, kind of putting it in the shadow. That looks like about 30 or 40 thousandths. So what I'm going to do is move the whole part in towards the head and take off that little tiny ridge. And well, let's see, look at 60, 40. Okay, I'm going to take in 10, 20. I'm going to take 30 thousandths for a start. Alright. Yep. So you can see that right here in this corner, this little brush is not much good for this, but this little tiny edge right here needs to come off. I'm gonna just keep on taking it in until I'm about where I'm scraping the grease off. That's probably about 40 or 50 thousandths. So we'll just crank it back. This is a power feed, but not power reverse. There's the start of my cut. For some reason my motor don't want to turn on. Let's try this again. This energizes something. Huh. Doesn't want to kick in, so I'm going to fool around and see what this is wrong. I just needed to bump the belt a little. So I'm at 70, there's 10, 20, there's 30 thousandths. I'll give this a go. I think it's probably about 50 thousandths. Alright, I'm down to the last cut. Starting to show some signs of heat. 10 thousandths. Now I'm just taking oil. Because it's cutting the whole width of that cutter now. And if you can hear, I slowed the machine down a long ways. You can see it starting to smoke, so mostly what the oil does is keep it cool. I don't want to run my head on it. Or my cutter rather. So it's a little messy, but it's going to give me a real nice surface. I'll make one more cut and I'll raise it like 5 thousandths, so it'll cut one even pass all the way across and it'll look real nice. So just a little bit of a tutorial on a horizontal mill. Well, here's our mill afterwards. Here's all this cast iron residue with oil in it, and this is what it looks like here. So it's not all that pretty, and it looks like I did cut it a little too much on this one end, probably because my clamps were not that good and it moved a little in the machine, or else I didn't have it set up straight, who knows. But I just have to clean this all up and get rid of the metal on it, and I should be good to go to see what it looks like. Alright, I used some kerosene here. Then I just cleaned it up and hit it with a rag, but it makes it real easy to see what I was doing. But it's all nice and square now, and My bolts will hold it straight. It'll be much stronger. And this will be the last machining I do to this, so now I'm just going to take some more kerosene. I don't have much left, but I'm going to go inside here and you can see there's a lot of metal shavings and file shavings and stuff inside of here, and I'm just gonna kind of flush it down and try to clean up all of this grease and metal shavings and stuff that is picked up over the last 40 years or whatever. And then when I get done with this, I'll blow it all out with air pressure, and I shouldn't have any stuff left in it. I can tell right now it's a little hard to turn because I've still got metal chips and stuff in it. This should be, I could actually see them in the teeth. Yeah, now it's spinning pretty good. I'm sort of washing out all the grit from the last forever. And we'll just clean this all up real good. This should make it run very smoothly and all will be good. So, next thing that I'll be doing is putting all this together. How you can see in here is a lot of junk, grease, and stuff. We're just gonna finish cleaning up everything we can get to and put it all back together. Next thing will be, once I get it mounted on the lathe again, then I'll have to do some more work on the transmission. But the part isn't here yet, so for now I can still clean it and remount it. Well, here's our results back on the lathe. Much stronger than it was. I'm yanking on it now and I can't see it move at all. I didn't have the right size bolts, so I got some washers and stuff. It's still not perfect. I can see that there's a little gap in the bolt. It's not perfectly parallel, but it's a lot closer than it was before. And anyway, the proof in the pudding is that it's holding it very tightly, and that should make things much better. I should probably make some kind of a brace or something to go in here and also bolt it to a different place. This bolt here was giving me a little trouble. I may replace that one and put a bigger bolt and retap and redo the hole that goes into the lathe. But anyway, it looks pretty good. It's obvious that I'm a few thousandths off on the alignment, but I don't know whether that's my alignment or whether that's actually in the casting. It could be a little bit of both, because it is just rough cast. Anyway, looks pretty good, and it's holding it tight. So that was one little project that's over with for now. Well, here's my new double universal joint. This one's got really nice bearings and needle roller bearings in it, so it'll work very good. It's big though. Here's a comparison. I cut the other one down to try to get some room. This one's man, an inch longer. I'm going to try a little setup here to just see where it's going to start interfering. Well, here is roughly where it goes. And with the carriage in this far, it looks like I can probably reach into the end of this chuck pretty well. But man, this is a huge joint. It's going to fall out now. It's quite big. I can probably cut off maybe about half of this one. I can cut it at least to where the thread goes in there. I can turn that much off on the lathe on both ends. This is a double D. It's a couple squares. I'll probably make this one for this end here. So I might be able to get maybe 1/4 of an inch off of it. Let me run this in again. Well, don't know what to say about this. I can run the cloth side in because see, I could see that's all the way in now with a cross slide. I can't really do anything with a straight tool bit at this point. This part is already over to the left as much as I want to take it. Anyway, that's our next little project. One of the things I do like about this one is that you can take these universal joints apart, so I can clamp each end in the lathe and trim some off. But I'm just looking at the difficulties of this to make it fit, and then it's still going to be way big. Well, I'll take it apart and see what we got from there. Well, there's just no way can I mount this in the lathe. My chucks are not big enough. I made a small attempt at taking one of these U-joints apart here. I can use a cutter in the mill here. I can make this go right enough and set it up square, and I can mill a little bit off. I can shorten it probably about to the middle of that bolt hole there, and this will be the end that goes up here against the gearbox. And then I'll have to somehow take that lathe screw out. I may be able to figure out some way of boring out a hole in something and make some kind of a mount for this. and put it in the lathe backwards. Maybe run a drill bit from the from the lathe to this and mount this on the tool post somehow to bore this hole out, because this is a splined hole. And of course I've got a 3/4 inch round shaft, so I need to have a 3/4 inch hole in here. So that'll probably be the deal. Make something that'll hold this, bore hole the exact size, put some kind of a clamp on it so I can mount this on a tool post. I do have a vise that might work, and try to bore a hole here, and this end I'll leave alone, and I can shorten it with the mill as I just described here. I guess the first thing would be to try to get this end bored out, but anyway, that's a bit of a project. I've got some stuff to do today, so I won't get started on that right now. Alright, I think I solved my situation. This fits into the forejaw about that far, and I've got this piece of aluminum here. I can put in the chuck, and it's going to give me enough room to clamp this centerpiece here, so I can bore this thing out. I'll have to fool around with it. First thing is just to get a hole bored in here so I can get it clamped on this outside of the U-joint. I have to get it to a perfect length. Might be a little bit of a problem because the bearing is sticking up a little past it. I'm not sure what I'll do with that, but I could probably put it on from the other side. I don't know, but anyway, I got to bore the aluminum to the size of this thing to make like a collet to hold this whole situation. Now, first thing is just to bore this out. I'll start a pilot hole in the center. So everybody that watches the lathe videos, this is probably very boring to you, but a lot of my friends have never seen anything done on a lathe. So anyway, this is just part of the project. I guess we could call this some way of holding a regular part. And now I'll just change these bits. That's a starter drill. I take it out, and I've got this huge one here. That's about a 3/4. So I'm just gonna throw this giant bit in here. I don't care how accurate it is really, because I'm just I'm gonna bore it out with a boring bar past this. And we fire it up. Look like the drill's in real good, so I'll give it another slap here and tighten it down good. There, now it's holding. That's pretty fast speed, and it's got a chatter in it. Yeah, that's better. And all I'm doing here is just feeding it in by hand. You can see that I've got marks on that. Well, I'm going to put this down and do it with both hands, make it easier. Okay, next thing, I've got a little boring bar set up here. I'm just going to, I have to do it all by hand. I'll just call that 0. Down here I'm going to take off about, that'd be 30 thousandths. We'll just try 30 thousandths. Yeah, it's taking 30 thousandths pretty easily. And I'm still at my medium high speed. That's a carbide bit on there, and it's pretty chewed up. I'm going to try a little different boring bar, go with the tool steel. Okay, I swapped out a different kind of bit. I'll back it out here. I've just contacted. Now I'll take another, say there's 10, 20, 30. That's about 60 thousandths. That's a pretty good cut for this lathe, but yeah, it's taking it out fine. And I'm just feeding it in here by hand. It would look a lot better if I had the mechanical feed screw going, but that's what I'm trying to make. So just trying to feed it in as smooth as I can. Really not important at this point. I got to get quite a bit bigger, then I'll start measuring it. We'll take another 10, 20. I give 50 thousandths altogether. Yeah, it's taking that much easier. Actually just very roughly just hogging this out. I'm not trying to be too smooth or anything. When I get close to where I want it, then I'll start using more precision. As you can hear here, this thing is chewing up real rough, and you can see the chips are all coming out chunky. Taking my time on it here, but it's really not cutting very well. So I'm going to try changing my tool bit setup here. Something, oh yeah, see the whole tool is turned. So I'm going to shorten it up anyway. What I did here, just run the, you can see the end of the tool in here. I just ran the carriage up against it, and so I can shorten it that much, and then I can get more of a clamp on it when I clamp it down and give that a try. We got the tool all shortened up. The next thing we're going to do is set the tool height, and it should be exactly on center. So as you can see, I can move this up, and what I want to do is set it as near as I can, or just a fraction below center. And then I tightened it with that top thing. I'm going to run it in here and see what yeah, best I can tell. I don't really have good glasses on, but that looks like almost exactly about center. This is controlled by this height, and then what I can do is loosen this big top one here, which allows me to rotate the thing, and I'll get it set up there to where it's just about 90 degrees. It's not that important actually, because if this is a little angle, the cutter hits first, and it's held in good and solid now. I just ran it in to 0. I'll try a pass. Yeah, see, it's cut much smoother. Here's that part where it rotated inside. See, I saw it move. I didn't really tighten that up as good as I should have. So anyhow, I'll get set up and we'll just continue to cut. Now I'm just taking a quick measurement here. If you can see this or not, getting used to doing this left-handed. I just find the diameter here with my calipers, and it's about 185, and I've got to go to quite a bit bigger. Let me turn this to the side here. I got that one there, right? See, because this is the piece I'm going to clamp in the hole, and it says 630, so I got a long ways to go. I'll just keep hogging away.